Hello everyone, as a continuation of my lecture series in control systems. So we have we are learning about the stability analysis, in which we have discussed in detail about the Routh-Hurwitz criterion, which is one of the method to find the stability of a characteristic equation. Whereas we are continuing with root locus technique. This is another method which is used in order to find the stability of the system. So the part of the graph which is shown in the slide, it indicates we have to first calculate what are all the things that we have to calculate, and we have to mark it in a graph in order to find the stability of the given transfer function. So why this topic is important? Again, without stability, it causes many problems in industries. Control system engineering gets affected, and manufacturing industries and automation sectors. So when now we are telling about all the industries are automated, and the main part of automation we go with control systems. We have many mechanical and technical calculations in order to find the stability and frequency analysis, time response analysis, and what is the response of a system when we go with change in time or change in frequency. So all these we have discussed in the earlier sessions. And what is the impact if we are not solving is safety hazards in automated systems and significant economic losses. So we go with need for the solution. So limitation of existing methods, and what are all the technology gaps and how we are going to determine is, first we have trial and error approach, in which inefficient and time consuming method for stability analysis. And behavior prediction, it is difficult in predicting system behavior as gain varies. So gain keep on varies when we go with feedback analysis. So it is very difficult to predict the behavior. So in order to find the gaps in the technology, graphical method, so need for visualization representation of pole movement and systematic design. So lack of systematic approach for controller design. So coming to introduction to root locus technique. So first, it is a graphical representation of how a closed loop poles move as a system parameter, and it varies from 0 to infinity. Can be visually seen using this root locus graph. So its historical background, it is developed by W.R. Evans in 1948, and the purpose was it to analyze and design control system graphically. So before which we were discussing about the theoretical and analytical part, whereas here it can be analyzed and designed using graphical method. So basic principle of root locus is we will have a characteristic equation again. So G of S is equal to some numerator by denominator, and all points on the root locus must satisfy both the conditions. So construction of rules of root locus is, first one is number of branches, which we are going to determine the number of poles and number of zeros. So from the given characteristic equation, we can determine the number of poles and zeros, whereas the pole is if the numerator has one constant value and a parameter which s plus 5 or s plus 10. So that 10 is a value for zeros. Whereas in the denominator, we have parameters like s plus 5 and s plus 2. And that 5 and 2 mentions the poles. So the value in the numerator is zeros and the value in the denominator is poles. And second point is we have to find out whether the root locus is about the real axis. So we have to point the poles and the zeros which we have identified, and we have to form a graph with the left hand side of part. So now we have to determine what is in which part the root locus lies in. That will be the second step. And third step will be calculating the asymptotes and centroid. And after calculating the asymptotes and centroid, we have to go with breakaway and break-in points, and we have to find the intersection and imaginary axis, and we have to sketch the complete root locus using all these values. So its properties and interpretation, like stability analysis. So system is stable if the root locus lies in left half plane, and the poles near origin means slow response, and poles far left means it is fast response. So all these. Coming to damping characteristics, we have you learned in unit 2, which is over damped and under damped conditions. So if it is over damped, then poles is on real axis. If it is under damped, then it is complex poles. Coming to the applications, motor speed control, power system stabilizers, PID control design, and filter design. So in this lecture, we have clearly explained about the root locus technique, which is another method to determine the stability of the system, in which basic principles and construction and steps to mark the root locus in a graph. Step-by-step procedure has been discussed. Coming to the properties and applications. Let us meet in the next video. Thank you.